Thank you, and good morning. I will present some results of a study we did in Murmansk in the Russian Arctic looking at black carbon emissions. Black carbon is the second or third likely largest forcer after CO2. The importance of black carbon is increasingly understood. And black carbon has a particularly pronounced impact in the Arctic because of the way it interacts with clouds and because of the way that it can deposit on snow and absorb solar radiation instead of reflecting it. So, but there's very little data on Arctic emissions, and in particular from Russia. So this project was part of a larger initiative that the State Department and various other government agencies funded, looking at several sources. In this case, we were concentrating in particular on diesel, but there were parallel projects looking at biomass burning and also industrial sources. So the objectives of this presentation and the inventory part of our project, well, I'll give you the objectives of the inventory itself, the methodology, and then some of our results. Russia obviously makes up a very large share of the Arctic, so it is very important in terms of understanding black carbon emissions. And diesel emissions within the Russian Arctic contribute substantially to Arctic concentrations of BC from what we can see, because there is a lot of combustion, particularly in industrial sites, so mining, et cetera. We did a bottom-up detailed inventory of BC emissions from diesel sources in Murmansk city, and then also for some non-urban sources for the entire region of Murmansk. We also did a very simple extrapolation of our results to all of Russia. And just to quickly summarize the inventory approach, we took a fairly classic inventory approach, meaning we were collecting activity data, how many vehicles are on the roads, how much fuel are they using, how often are they driving, how many mining vehicles are there, what types of activities are those mining vehicles engaged in, how much fuel do they use, how much do they idle, et cetera, et cetera. We looked at the extent of control technologies on the diesel equipment and vehicles from a wide range of sources, and then we would come up with an estimate of the total PM 2.5 emissions, and then we would use speciation factors for each type of emission source to calculate black carbon and also organic carbon emissions. So that's in a nutshell. One of the most challenging aspects was that a lot of the statistical data available from Murmansk was not consistent. And so trying to put the data together was a major challenge. We ultimately constructed our own analysis of the diesel fuel consumption, looking at both the existing sources that the statistical agencies produced, plus our own calculations based on the amount of traffic we were seeing on the roads, for example, from detailed traffic surveys that we did in collaboration with a university in Murmansk. We took a similar approach for some of the other sources like fishing. Mining the data, our bottom-up calculations of diesel consumption meshed very nicely with the statistical data that we had, which was nice. And for a few sources, there was not, we didn't have enough data to do alternate calculations. So, but those, for all the large sources, we made sure that we found alternate ways to do bottom-up fuel consumption calculations. So for on-road transport, a couple of the highlights. We found some very interesting results. So we did, just in terms of the kind of measurement we did, we had students out on multiple street corners conducting measurements of the volume of traffic and the types of vehicles they were, meaning, is it a truck, a bus, a car. We also did detailed parking lot surveys, which tells you what vehicles are actually on the roads today. And then we compared that to the detailed registry. We got a registry of all the vehicles in Murmansk and tracked that to which ones are diesel operated. So by combining all of those, we could tell that, in particular through the parking lot surveys, we could tell what share of the vehicles on the roads are diesel vehicles. in terms of what's actually driven. It was 12%, which is quite a bit larger than other estimates for Russia. And that's to a large extent, we believe, because of the trend towards more and more luxury vehicles, which tend to be diesel vehicles in that part of the world. The share of vehicles with emission controls, and this is, I think, an important finding, is much higher in terms of our detailed measurements compared to what the registry shows. So that's really good news. That means the emissions effectively are lower than other global estimates might show, at least for transportation. In addition, a large share of the vehicles on the registry are not actually driven in a given day. And this is quite common for many countries that are emerging. We were able to calculate exactly what that difference was. So only 40 to 50% of the vehicles on the registry were in use in a given day, and a large share of them are never used. In terms of the largest emission source among the transportation sources, Euro 0 trucks were very important. So basically the trucks that have no emission controls represents a large opportunity in the future if they could switch out those fleets. So looking at the black carbon emissions from Murmansk city broken down by Euro class, which basically indicates the level of controls, where Euro 0 is no controls and Euro 5 are the highest level of controls that they typically have in Russia. Currently, today in Murmansk, it's mandatory to have at least Euro 4. But of course, there are vehicles that people had purchased previously that don't meet that standard. And you can see Euro 0 is by far the largest, not just for trucks, but overall. When you look at the breakdown by different types of vehicles, cars, trucks, buses, and so on, and also the breakdown by cold start, when the vehicles are starting up, they tend to have a burst of emissions, versus their hot stage emissions. The overwhelming majority was the hot stage emissions, but again, trucks contributed substantially, even though they were not as large a portion of the fleet, because so many of them are Euro 0 and because so many of them drive many, many kilometers every day. So we also, in our inventory, we looked at many other black carbon sources. Because this presentation is focused more on the urban sources, I paid more attention to the transportation. But I think with off-road vehicles, there's also an interesting story. The mining industry in Murmansk is the single largest consumer of diesel by far. They produce a number of minerals in open pit, primarily in open pit mines, like fertilizer products, something called apatite, and other. Also construction and road management vehicles, including snowplows. It snows a lot up there, so snowplows are actually a relatively significant source compared to most places in the world, and we looked at them separately. And they have reasonably good data on their snowplows. We looked at locomotives, rail locomotives, diesel generators as well, and fishing vessels. We excluded a couple of sources because of sensitivities, so we purposely did not look at military, which we guess may be a large source. We also did not look at the commercial port because of sensitivities from the Russian government. We felt like it was more important to be able to get access to all the rest of the data. So this is a summary of our emissions calculations overall, both for PM2.5, black carbon, and organic carbon. And a couple of features. Mines clearly stand out as the largest source overall, followed by on-road transportation. Some of the other sources were surprisingly large. So locomotives are quite large, which is very surprising in Murmansk because almost all of the rail is electrified. They have just a few locomotives, like inside industrial plants, or the locomotives that build trains for long-distance freight. Those run on diesel. And just that very small share resulted in a substantial source. Because those locomotives are very old, no controls. The diesel generators were a large source, and we spent a lot of time looking at it, thinking that off-grid generators would be a major source. Turns out they're not, because they don't operate that many hours per year. But what did appear to be a much larger source were many very, very small diesel generators that people who work in markets or in kiosks appear to have. So they might have a diesel heater or a small diesel generator, and cumulatively, that's a fairly large source because there don't appear to be any controls. Fishing is not a major source. They have a large fishing port, but most of the fishing fleet spends the majority of its time very far from Murmansk in South America, Africa, and so on. And agriculture, for obvious reasons, it's an Arctic region. There's not a lot of agriculture. We spent a good bit of time looking at uncertainty, and we tried several methodologies to reduce uncertainty. Given the time, I won't spend more on that, but we also extrapolated to Russia-wide, and Russia-wide transportation is a much larger source because transportation overall in Russia is a larger source of diesel use. Also, agriculture Russia-wide would be a large source because there are no controls on the agricultural vehicles, and in more southern parts of Russia, agriculture is a major industry. So a couple of top policy conclusions, and with that I'll end. On-road vehicle emission control regulations that exist in Russia have clearly had a strong and positive impact in reducing emissions, which has had a major positive impact for climate and for health. Fleet upgrades we think, can play an important role in reducing emissions. We've worked with the bus company up there in changing their fleet and reducing emissions. Obviously, there are some opportunities with trucks as well. A comprehensive government policy would likely be very beneficial in improving air quality monitoring system. Right now, they have very little air quality monitoring. And off-road vehicles represent one of the largest opportunities that they have today in terms of a relatively simple method to reduce emissions by requiring some level of controls on new off-road vehicles. Thank you.
Thank you. And we have a few minutes for questions. Well, I have one question. I was wondering, how do you estimate the emissions from fishing activity?
So from fishing, what we did is we took detailed data from the port registry and also from marine tracking systems. And then we, based on those registries, both the registries of port calls and the registries of the vessels that are in port, we could estimate the energy use, and then we made some estimates in terms of the number of kilometers they would have to travel. For the smallest vessels that we looked at, they don't show up in port registries, so we had to make some assumptions on them, and we verified that with local fishing experts.
Another question. You mentioned, was this partially commissioned by or supported by State Department?
So the State Department supported it, and then worked with, in the case of this project, with the Environmental Protection Agency. But also the Department of Energy and the U.S. Forest Service were involved in other aspects of the project.
So I was curious, it was motivated by the climate clean air, I forgot the name of the policy, but was there also a push to look at methane, perhaps?
So with this one, the original motivation was the Arctic Black Carbon Initiative. And so it was a bilateral initiative. And also, this particular project is under the Arctic Council. Gotcha. Obviously, it's a little bit more challenging politically now because there are no more bilateral projects with Russia. So,
thanks again.
Yep.